Hi, everybody. My name is Emil Lerch. I'm a principal consultant with AWS. I work in the professional services public sector team. I've worked with Beth Israel Deaconess Medical Center on their HIPAA deployment. I also have worked with several other customers, working with a couple right now, actually, that are subject to HIPAA regulations, as well as some others in the past. So I have a pretty deep hands-on experience over a long period of time in this area. I do have to apologize up front. Chuck was unable to join us. He had a last-minute scheduling conflict. That said, I did work with Beth Israel Deaconess for quite some time on their setup, and I'm pretty familiar with it. So he and I spoke as early as 45 minutes ago on some of the details that have happened since I've left that account. But I hope I can do that justice. So welcome again. I know it's a first session in the conference, and so it's everybody's still trying to figure out where rooms are and all that kind of stuff. So thank you for being able to make it and make your way over here. First thing I kind of wanted to go over was I just wanted to level set on what this topic really is. I wanted to reiterate that this is it's in the session summary, but this is a relatively advanced talk. We're not going to be going over the definition of EC2 and VPC and S3. If you're not familiar with AWS terminology, this might be a little bit too technical for you. What I really wanted to get across was some of the specific things that Beth Israel Deaconess has done that I think that were particularly well planned out and generally useful to a lot of customers that are in the process of implementing environments that are subject to HIPAA. And so, we do get in a pretty good level of detail on this talk. So if you're not familiar with AWS terminology, you're not familiar with the networking terminology and the storage and things, this may not be the right session for you. So really what we're trying to go for here, folks that already kind of get it and want to do more. They want to implement higher level security type workloads on AWS. So HIPAA. Title is HIPAA and HITRUST. HIPAA is the Health Insurance Portability and Accountability Act. It's a federal regulation that was put in place. As such, it's relatively high level. It doesn't get into a lot of technical details. It's not very prescriptive. And so because of that, industry actually came through and said, okay, well, we want something that's a little bit more prescriptive. So HITRUST is the Health Information Trust Alliance. They came along and they said, okay, let's put something together that can help folks with very specific requirements and a common security framework that you can use to implement security for workloads that transmit, store, or process protected health information, or PHI. So that said, what I really want to do is get into what Beth Israel Deaconess specifically are doing, what they have done. Beth Israel Deaconess Medical Center is part of Harvard Medical School. They're a nonprofit, and they are focused on clinical care, teaching, and research. So they started their journey to the cloud about 2.5, 3 years ago. They started looking at AWS. They wanted to come to AWS, get a lot of the benefits of AWS. And so they started engaging both with their account manager, solutions architect, and then brought professional services on to help design a system that can handle PHI. So they have 1,200 physicians, 670 beds, and they're focused in those three areas. So why did they move to the cloud, right? The primary impetus for them to consider other options was their data center lease was expiring in 5 years, and so they wanted to evaluate other options. When they looked at AWS, they saw that they can have higher security, that they can take advantage of cloud features to innovate quicker, be more agile, but they also wanted a stronger disaster recovery and backup story. Their disaster recovery site was located about 2 miles away from their primary data center, and so they wanted to be more resilient to failures that, natural disasters and such that would affect the region. And so AWS was a natural fit for some of those things. So they started out, the services that they're using were kind of the basics. You got EC2 and S3. Of course, to just get started in AWS, you have to start thinking about how you're going to do your networking. We'll get into a lot more depth later on about how they do their networking. But they set up a direct connect, VPN backup. And they have quite a bit of thought put into how they do their VPCs. One of the things that I wanted to call out here is in the management area. They have a number of different things, CloudTrail, CloudWatch, CloudFormation. CloudFormation specifically was a very high priority for Beth Israel Deaconess. When we've first started talking to them, they were very clear with us that they wanted to do things that aligned with AWS best practices, right? And what we wanted to do was make sure that everything was scripted, that everything could be audited, that we could see how things change over time. And so CloudFormation was a very high priority very early on. So everything that they do, everything they touch in their environment is scripted in CloudFormation. It's put in version control. It's audited, it's verified, it goes through a series of reviews by different groups, and then finally it's deployed. And so they have a very prescriptive methodology for doing that. It probably took them, I would say, 3 to 4 months to kind of get a nice mindset change to using CloudFormation. They knew that they wanted to do this. They saw the benefits of all the visibility that they had into their environment by using CloudFormation. But they have network engineers. Chuck was actually one of them that comes from a networking background, and now all of a sudden it's like, well, how do you use version control? How do we do these things through these scripts and through CloudFormation templates? And not just going in and configuring routers and things like that. So there was definitely a cultural aspect to their AWS adoption, as well as just the pure technical aspects of it. But that CloudFormation was a big piece of it. Another part that kind of goes along with CloudFormation is Service Catalog. I don't talk about it much in subsequent slides, but Service Catalog allows you to have a portfolio of CloudFormation templates that can be deployed. So you can provide some governance and self-service for applications that want to deploy something that's already somewhat pre-approved, so you don't have to go through a series of review steps and stuff. So they are using Service Catalog, and it's been working pretty well. So their account security, and I think that this is a really interesting kind of story based on where they were at the time. There's a lot of history that's on this slide. So 2.5, 3 years ago, we started talking about using multiple accounts, getting single sign-on, SAML federations set up in their environment. And we had a plan together, and the plan, when we started taking a look at all the details at the time, there was a dedicated instance fee. And the dedicated instance fee, the issue was that to have PHI in your account, you have to sign a business associates agreement with AWS. That business associates agreement requires that any PHI be using HIPAA services, HIPAA eligible services list. At the time, there were only about 6 services that were eligible for use on HIPAA. But also at the time, this is no longer a requirement, but they, at the time there was this dedicated instance requirement that said that any PHI that's transmitted, stored, or processed needs to be on single tenant hardware. And so within AWS, there was a dedicated instance fee, $2 per account per hour, and that was a significant cost to them. And so when we had all these great diagrams with all these multiple accounts on them, they said, well, we don't want to pay for the dedicated instance fee in all of these accounts. And so we landed on the account architecture that you see here. And so what we've got there is production at the top that includes anything that would be processing, transmitting, or storing PHI, and then dev test, which we're going to keep PHI out of, and they have an Explore IT account, and I'll talk a little bit more about this. But Beth Israel Deaconess, as part of their mandate, is looking for new ways of working with medicine. They want to do telemedicine. They want to involve mobile applications into medicine. And so this is kind of their account that's not really connected in with their on-premises network. It's for kind of art of the possible proof of concepts. And so that particular account was also assumed not to have PHI. And so this was their original account architecture. What they want to do now that the dedicated instance fee is no more, because now that the requirement's not there for dedicated instances, they can split those accounts apart and start moving VPCs into each account. That work is planned, but not completed at this time. But they have multiple accounts. One of the things that they did early on was they made sure that they were handling the root user correctly. So they have one of their groups has the username and password for the root account, and then another group has control over the hardware MFA token that is needed for multi-factor authentication into the account. So you need to have both groups agreeing that the root account, somebody needs to actually get in there and do something with the root account. Otherwise, they're going to be prohibited from doing so. On the IAM side, when they have IAM credentials, those also have MFA, but those are the soft MFA that's available through Google Authenticator or OpenOTP or whatever. So that's how they're working with that. And then later on, when they started having multiple accounts involved, at that point they said, the local IAM administration doesn't really scale, and so we want to use identity federation. So they have a SAML 2.0 identity federation scheme that's used within their environment. So this is how the SAML piece of it works. When a user wants to sign in, they go to their identity provider. Their identity provider is then integrated with their Active Directory services, and you get authenticated through the identity provider, and then it comes back into AWS. You'll end up with temporary credentials assuming a role within AWS. That works through the security token service underneath the covers, but that in turn allows you to get to the AWS console. From a networking perspective, the previous slide was a little bit probably hard to read in the details from the VPC, but they have each VPC is really based around a line of business. So they're clinical. They have a clinical VPC, a research VPC. They have one VPC that's specifically for analytics. They've got their Explore IT VPC, and so these are designed around kind of the high-level organization, breakouts, things that they don't expect to have changing all the time. If you have a lot of organization churn and changing of groups, you don't want to have to change your VPCs accordingly, and so they try to be fairly high level there. They've got direct connections into each one of the VPCs. They've got a hub VPC that hosts all the shared services, their DNS, their Active Directory, security and auditing. That's all in the shared services piece of things. And then they've got a VPN backup. So they're 10 gig direct connection with a VPN backup in case something happens to the direct connect. And then lastly, the VPC flow logs. So the VPC flow logs are there for a number of reasons. The most useful thing from a day-to-day perspective is being able to tell, if things are blocked due to a NACL or security group, they can actually see that that's been denied. And then they can come back and see, okay, this wasn't a routing issue, this was a denial based on a rule of some sort. So they've got VPC flow logs enabled on everything. So this is kind of just a diagram of what I just explained. They have the 10 gig direct connect. One thing to note on this diagram is that you won't see, there's two things you won't see. One is the Explore IT VPC that is not connected to their on-premise network. And so that's kind of handled separately. And the other piece that you won't see is an internet gateway. They have things completely walled off from the internet, and any kind of internet connection that needs to be made will be backhauled into the on-premise network and go out to the internet from there. I'll get into a little bit more about why that is later on. From an EC2 perspective, we want to encrypt all the things, and so they have encrypted AMIs, encrypted data volumes. All their EBS volumes are using encryption, and so they have that in place. They're using Bastion hosts exclusively to be able to connect to their production instances when that's needed. So their security groups are all set up so that the Bastion hosts will only take connections from the on-premise network, and then their production EC2 instances only accept connections for RDP or SSH from the Bastion hosts. So they have to do any administrative tasks through those Bastion hosts. And then the security group design. There's a fair amount of thought that went into their security group design. I think that they've put more thought into this than any other customer I've ever worked with. And so there's a whole separate slide on that, which we'll talk about in a minute. To show you kind of encrypted EBS volumes, this is all you really need to do. So this is a snippet of a CloudFormation template, one of their actual CloudFormation templates, and all you have to do is set that encrypted to true, and you've got an encrypted EBS volume. Of course, on top of that, you can also put a file system that involves encryption as well. That's within kind of the host software and outside of what Amazon provides. But this is, from a base level, this is really all you need to do. So there's security group architecture. This is, they put a lot of thought into the security group architecture. I'm pretty impressed with what they have. So it's a little bit hard to read, but the security groups that are outlined in blue that you see at the top and on the left, those are pre-configured security groups that are available for shared services. So when when they have agents on the systems to do auditing, logging, that kind of thing, they need access to different ports and different services. And so there will be a security group that's assigned for that purpose. There's a security group for DNS, for instance, so that the instances can go out and talk to the DNS services. So there's a number of different kind of base things, Active Directory being another one, that get applied to either every instance in their fleet or certain classes like Windows or Linux need access to different things. And so they have a core set of shared security groups that have been pre-vetted by their teams and have been scripted and can just be applied directly to an instance. At that point, you've got kind of the base connectivity that's needed to be able to work with within the Beth Israel Deaconess environment. And so we still need to be able to apply additional rules for the application itself. So that's what we see on the red when we look at the right-hand, lower right-hand portion of the slide. The red security groups really represent the applications. So these need to be individually vetted by their teams and scripted before they go out. But they will put different application security group together on a per tier basis. So the load balancers that handle the front end traffic get one application security group assigned to that. Their web tier will get another one, the application, and the database will each get their own individual ones. Between security groups, so the web tier will only accept connections from the load balancers, and they don't do that by IP address. They can reference the other security group directly. So rather than seeing an IP address in the template, you'll see an SG dash, blah blah blah. That references the security group by name, so that if anything changes, that reference is still there. Okay, this is what it looks like when they start putting together the CloudFormation templates. So the things that are highlighted in yellow, you have to set up the VPC ID. They're using the source security group ID again by name, not by IP address. And then obviously specify the ports. In S3, this is also something that's kind of changing over time as they move forward with their AWS setup. They've got S3 security that's enforcing encryption. They're filtering it by source IP. So all S3 traffic needs to come from their public IP range that represents their corporate network, and so they know that any of the S3 traffic is restricted directly to Beth Israel Deaconess. The encryption, if it's not requesting server-side encryption, the operation will fail. More on that in a minute. And then they're using IAM roles to enforce those permissions. So it's a combination of the bucket policy and the IAM role that really allows access to S3. And then they've got monitoring turned on all their S3 buckets. Okay, this is what the CloudFormation template looks like for the S3 bucket policy portion of it. They have the condition for S3 server-side encryption to be true. This will fail. Moving forward, what they want to do is actually remove that condition, allow data to come in unencrypted, but then pair that with a configuration change on every one of their S3 buckets. It takes advantage of a new feature that we have that allows for default encryption. So if you don't specify the encryption on the S3 bucket, we'll just go ahead and encrypt it with what you've specified in the configuration. So that way, rather than just denying a request, they'll just do the right thing. But you can see the source IP. We specify the public or the public range, IP range, in addition to an internal range. So if the request is coming over the direct connect VPC tunnels, it'll get the 10 dot. If it comes out from the outbound public IP, it will come through that 134. And that's all you really need to do in terms of the source IP. So as long as you know your public IP range, it's relatively simple to put together. Okay, so the challenges that they had, and there's a couple different bullet points on here that are specifically interesting. to understand from a historical perspective. So the first bullet on here is the layer 7 firewall implementation. They don't have an internet gateway on their VPCs. They're disallowing traffic, and what they do instead is that they have a layer 7 firewall that sits on the direct connect connection so that they can monitor all the traffic at their in their on-premises network. And the reason for that is twofold. One is that AWS Web Application Firewall was not HIPAA eligible. It is now. And as a result of that limitation, they were forced to a third-party implementation that would be cost prohibitive to do otherwise. And so they're inspecting all the traffic on-prem using an on-premises device. And so the AWS WAF is now available, and so they are looking at that as a potential change that they want to make moving forward. Managing local IAM users. So this is an interesting one. There's a balance here in terms of high availability for your IDP. And so they do have a few local IAM users that are available in case there's a problem with their IDP service that bars them from being able to authenticate and get into AWS. What they found early on, though, is that they really needed to prioritize the federated sign-on, and the reason for that is just managing local IAM users across multiple accounts. When they got to a certain point, they were finding it was just difficult to manage, and so that was a problem, and they had to kind of reprioritize things. Encrypted AMIs between accounts. So what they did here was they just shared an encrypted EBS snapshot between accounts, and that got the data between the accounts, but the AMIs themselves, they weren't able to copy between accounts, so that was an unexpected kind of wrinkle that they had to deal with. And then not all services being HIPAA eligible. You can only transmit, store, or process PHI on services that are on the HIPAA eligible services reference list. And when they started, I believe that there were 6, there might have been 7 or 8, but they had very few services that they could actually work with PHI. And so it required them to be very careful about how they were architecting their applications. Since then, especially in the last year, we've added a bunch of services to the HIPAA eligibility list. There's now even SageMaker and Recognition have achieved placement on the list. Moving forward, we're trying to get HIPAA eligibility for new services even on launch. I don't know if that will be possible, but that is something that we aspire to anyway. And so you're going to see a lot more services come, but Beth Israel Deaconess had to either re-architect or delay implementation of a lot of their applications originally in order to meet the requirements of that list. So next steps. So now that time has passed, technology's marched on. AWS has improved the services footprint and the new services that are available. They want to evaluate AWS Organizations. I'll talk a lot more about AWS Organizations in a moment, but they want to evaluate that for account management. They want to look at federated API and CLI access. Right now, they're still using local IAM users for API and CLI access. Using federated access is a little bit tricky, and so they want to look at that. They aspire to do it that way, but they want a user-friendly solution. So they're looking at that. They want to have a central security account, and I'll talk about more about the benefits of that later on. They call this one out specifically, but now Lambda is HIPAA eligible. And that opens up a lot of doors for them, especially a lot of the newer applications that they're looking at in terms of mobile applications for medicine, telemedicine. They've got a lot of great ideas that they want to explore in that Explore IT account, and Lambda has been central to that. The idea of using serverless compute has been really appealing to them for a long time, but they weren't able to use it. Now they can. So that's something that they really want to focus on. Okay, so that's Beth Israel Deaconess. I'll be referring back to their implementation a little later on, but I wanted to talk a little bit more about setting up new accounts and some of the things that you should really consider as you look to store, process, transmit PHI on AWS. So governance and controls, I talked about AWS Organizations earlier. Organizational policy can be applied through AWS Organizations. So for those that aren't familiar, AWS Organizations allows you to easily kind of manage multiple accounts. But if you look at the HIPAA eligible services reference list, Organizations is not on it. So I keep talking about how it needs to, we have to have the services on the list in order to be able to use it. What we have to remember is that the rule is that in order to store, transmit, or process PHI, you have to be using a service that's on this list. If you're not storing, transmitting, or processing PHI with the service, you can use any service you want. And so you can use any AWS service that exists as long as you're not putting PHI through that service. So if we think about this for a moment from the context of AWS Organizations, the types of things that it's storing, transmitting, and processing are things like account numbers and organizational identifiers and metadata about how you're describing a particular account. And so if you have an account that has like PHI in the name of it, that would be a problem. But most organizations, I've never seen an organization that would even think to put a patient medical record into account metadata. That's just not something we do. And so so you can use Organizations unless you're doing something like that. Which kind of takes us back to the shared responsibility model, right? So in order to kind of evaluate what we're putting forward there with Organizations, it's not on the list, but you can use it. It comes into the customer responsibility aspect of this, right? You have to understand what you're doing with the services and how you're using them. We also, provide EC2 on the eligible services list, but you need to make sure that it's encrypted, right, in order to use it responsibly. And so there's definitely that shared responsibility. In particular, it's acutely particular in HIPAA high trust environment, and so we need to take extra care, I guess, if we're working with PHI. So Organizations allows us to logically group AWS accounts. We can create organizational units. You can have groups within groups, and then place the accounts in this. Makes nice graphs, but it also does one other thing, right? You can have what's called a organizational control policy, and that policy allows us to say, in this account, I am only going to do these things, or I am going to disallow these things. We can do a whitelist or we can do a blacklist, and we can provide these policies. And the local administrators cannot override this. This is something that's done at a higher level. So if we look at an example, we've got a number of accounts. Here there's 9 accounts. We're going to put together 3 different groups within our organization. And then we will put together policies. So at the top, I've got a root level policy that says these are the only things that I'm going to be doing as an organization as a whole. And then on the right-hand side, I've got a policy that says for this particular group of accounts, I'm going to restrict it further. And then for account 9, I've got 3 other policies that I want to apply for specific things that I want to have that particular account either restricted or allowed to do, depending on if I'm blacklisting or whitelisting. Now I can attach another policy to another account. I can move the account from group to group, and that policy will ride along with it. And when that policy rides along with it, that's attached directly to the account. But now that policy is also computed in the context of the overall group accounts. So when we process the policy, we're looking at the root account, the group account, and the root organization, the group organization, and the account itself. We take an intersection of all of those policies, and that's what we're using in order to compute the final things that account is allowed to do. Another example, and this might make it a little bit more clear to show that intersection. Here we've got a multi-levels of groupings within organization. I've got my compliance accounts and my research accounts. When I look at, say, the clinical research, for instance, I'm applying the Acme Corp root policy, the research policy, and the clinical policy. I take an intersection of all of those policies, and that's what's going to apply to the account as a whole. Local administrators within the clinical account cannot override those policies. Those are all done outside the account. Doesn't matter what they do, it will apply. So we can do this, like I said, either with whitelisting or with blacklisting. Cannot be overwritten. And then you can use this in unison with your IAM policy. So the IAM policies within the account will also intersect with the AWS Organizations policies that are applied at the account level itself. And all of those will be used as part of the calculation for the final, this is what's happening with this particular principal and API and the resource that you're trying to operate on. The IAM policy simulator is also policy aware, so it will take into account what's happening at the AWS Organizations level. So when you're using that policy simulator, you can see the effect of the organization's policies as well as the policies that are relevant inside the account. Okay, here's 2 examples. Blacklisting example on the left, we can see, hey, we're going to allow everything for, accounts can do anything they want. We just don't want them to use Redshift for whatever reason, right? On the whitelisting example, we don't have that blanket global statement. We're just going to say, we're going to allow you a certain subset of actions on EC2. So we can run instances and we can do a bunch of describes, but otherwise we're not going to say anything about other actions that are being done. This allows policies later on to do further allows at a lower level and then have those allows. By default, if nothing is said about one way or the other about a particular action, the default operation is to deny it. So with whitelisting, you have to be all-inclusive about what you want to have allowed. Okay, we talked about Beth Israel Deaconess wanted to consider putting together a security account. One pushback that you see sometimes in organizations is I don't want to attach my my account to the AWS organizations of the group as a whole because I don't want IT to come take over my business and tell me what I can and can't do, right? So one thing that you can do in those circumstances, but is generally a good idea regardless, is to put together a security audit account. So maybe this AWS account isn't part of organizations, or maybe it is, but in either case, you can have a security account that has ability, basically a read-only ability into the other accounts to be able to see what's going on. within that account. I've also put this together in place in organizations that do not have the ability to use AWS Organizations. Some of my customers are working with resellers that are taking. They are connected into AWS. They have their own set of accounts, and then they resell accounts to our customers. We're working with those customers. They don't have access to AWS Organizations. They don't have access to the overall billing, but they can still have a security audit account because all the cross-account access is still available. And so they can have a centralized logging bucket like you see on the bottom, where every account is logging all their CloudTrail data into that bucket in order to consolidate all the log data. At that point, you can also have read-only access from the security account into all the other ones, and that allows you to kind of take static snapshots of what the configuration looks like, and you can do your rolling log analysis on the centralized logging bucket. Okay. Account access. So Beth Israel Deaconess had a problem with local IAM users, and the way that they solved that was the SAML federation. We have AWS single sign-on as well, but we can in any event it comes down to identity federation. What we want to do is have a single identity provider and then allow access into any one of the accounts. We set up IAM roles. We assign least privilege to those roles. And then when the identity federation, when the identity provider authenticates us, we assume one of those roles through the security token service. And that gives us short-lived credentials that we can then use to access the API or the console, what have you. The next question that comes up a lot is developer access into IAM. This can be a little bit tricky for development and test. This slide says it may require, in my experience in development, developers almost always require some access to IAM. For test and production, not so much. But CloudFormation templates will often have to set up things like, allow this Lambda function to be able to access this role, and that requires some IAM level permissions. One thing that I've seen used effectively not at Beth Israel Deaconess, but at some other customers, are to set up IAM roles that allow a developer to basically assume additional permissions for a short period of time. So this is analogous to sudo from Unix world, right? We want to elevate privileges temporarily, allow the developer to do what they need to do, and then come back out of it. And we see all of those things then logged through the API. And so that's something definitely to consider for your setup. All right, so this is what it would look like. This is what it would look like. The developer just assumes this new IAM role, gets them access to S3 where the pre-approved CloudFormation templates are. You can run the CloudFormation template, and then that in turn creates the resources. This is another area where Service Catalog can come into play, where you can set up Service Catalog to kind of do this aspect for you. You give Service Catalog the permissions to do things, and then you assign your end users access to launch the products in Service Catalog. Another option, and this is especially appealing now that Amazon Workspaces is available on the HIPAA eligible services list. A lot of research use cases in particular, right? You might be working with some PHI. Now you can actually work with that PHI in Amazon Workspaces. For a long time you couldn't. That's a relatively recent thing. But the idea here is that you actually don't let the code leave your protected environment. Your client can be running whatever it is, as long as it has access to Amazon Workspaces. We're just pushing pixels back and forth, and the actual intellectual property is in AWS cloud. So in this particular case, we've got Amazon Workspaces that peers into the VPCs that where you have the PHI, and then everything's kind of contained within AWS. Okay, so IAM. One thing that a lot of customers will overlook is IAM gives you a lot of access, visibility into what your users are actually using. So you can do things like use the IAM Access Advisor or CloudTrail to say, okay, my users are only really using these 15 services or 20 services or whatever. I'm going to start to peel back the permissions and all the stuff that they're not using over time in order to reduce my my available footprint, right? My attack surface area. So we do have customers using Access Advisor to say, okay, these things haven't been used in 6 months or never been used, and so let's put a new policy in place that says we're just going to deny that. The API keys. So IAM users have access key, secret key pair, as well as a console password. Some users will just be set up by default with an access key, secret key. Some will ask for it and then never use it. But if you're not using it, we can remove it from the user. There's a way to audit. Are they actually using that key? And if they're not, we can pull it, and then they can request a key when they actually need the access. This also will reduce the attack area for your accounts. Okay, other things. Trusted Advisor. In my opinion, customers don't use Trusted Advisor enough. It's there. It's a free service. If you've got business level support, you've got API access into Trusted Advisor, so you can use Trusted Advisor in an automated fashion to just do a basic best practices kind of check on your accounts. These can be run from the security audit account, and so you can automate this on a regular basis. AWS Config is a service that will also allow you to monitor your accounts over time and see if the security posture for your account matches what you expect it to be. So it's a great way to kind of audit things. Okay. We want to encrypt everything. I talked a bit about S3 default encryption is now enabled by default, and so you can make your own decision about whether or not you want to just prevent non-encrypted S3 operations like Beth or Deaconess is doing now, or if you want to enable default encryption and then back off on that bucket level policy like Beth or Deaconess is considering. It's kind of up to you which way you want to go. I do like enabling encryption by default and then maybe auditing to see what's not being specified, so you can follow up and see if that's appropriate or not. And then on the EBS side, EBS encryption is really easy to set, and then we can monitor that with config and config rules. Okay. Key management service is used for, it's integrated into a lot of different services, and because of that integration, it's super easy to use. With the EBS, it's just a checkbox. With S3, you can put on default encryption with a specific key, relatively easy. And then KMS grants allow really granular control over what can be encrypted and what can be decrypted. So you can say for long-term storage, your operations can do encryption but can't do decryption. And then your audit team is the only thing that is the only team that can do decryption. So it works out relatively well there. Cloud HSM, if you're old-time AWS, Cloud HSM was very expensive. We since have a new Cloud HSM service. It's FIPS 142 level 3. And that is a pay-as-you-go hourly rate, and so it's a lot less expensive than what it once was, and it's a fully managed service now. The old Cloud HSM was a real high-touch kind of operation. Certificate Manager allows you to have free SSL certificates. You don't have to do the CSRs. It's usually kind of a tricky process. It's straightforward, but there's a lot of steps involved, and so it's easy to kind of mess that up, but you don't have to do any of that. And then you get the automatic renewal, which I think is the #1 feature for Certificate Manager. Having that automatic renewal is great. Parameter stores is an option that I recommend to customers a lot for secrets management. It integrates with KMS for encryption, and so that it's a really useful tool and often overlooked. Since in the last couple of months, we've also come up with Secrets Manager, which goes a little bit beyond what Parameter Store can do. It's extensible via Lambda, and it integrates with RDS. So all your database passwords can be rotated now automatically, and encrypts with KMS, and it has resource level permissions, which is pretty cool. All right. Patching and validation. Systems Manager can do a lot of patching and validation without having to go towards something like Chef or Puppet or Ansible to do automatic patching. And one thing customers sometimes consider is just remove all shell access and use Systems Manager via the run command to actually be able to kind of maintain our fleet. Amazon Inspector allows us to schedule those assessments for compliance, so we can see, okay, there's a new vulnerability out there. Is any of my instances in my fleet subject to the CVE? Okay. And then securing the network, between CloudFront, WAF, and Shield, we have really good DDoS protections that are kind of built in. With Shield Advanced, you have a high-touch kind of person to call for that kind of thing, and then finally for 853, 800.171, if all of this stuff is kind of going over and you're not sure what to do, there's a couple different things you can do. You can use one of our quick starts. We have quick starts for NIST 853. There's also a HIPAA specific quick start, and then there's also every AWS account has an account manager and a solutions architect. Those are free services. You can also, of course, engage professional services, which is a more high-touch engagement where you have folks that are like me that are very versed in all things AWS and can do something specific for your environment. So that's all I've got time for today. Thank you very much for your time. I'll hand it back over to Layla. Thanks.